Hello PU2 champions, welcome to day 1 of 21 days challenge to get 95% in your second PUC final board exams. So as part of today's challenge, I have given you 2 chapters for homework, electric charges and fields from physics and solutions from chemistry. So I hope that by this time all of you have completed the challenge. If yes, let me know in the comment section by typing ma'am day 1 completed. If you haven't, do not worry. The link is there in the description section. Please click on the link and download the most important questions PDF and practice the important questions. Okay. So in this video, we will be solving the most important MCQs from the chapter solutions. I have taken almost 75 MCQs from this chapter. And if you just watch this one video, the entire MCQ part will be done for you. 3 marks will be coming from solutions chapter for MCQ, and that 3 marks will be guaranteed after watching this video. Okay, so let's get started and start with the first question from the solutions chapter, topic types of solution. The first question is camphor in nitrogen gas is an example of. So I have told you that one table is there in NCERT in types of solutions, which is very, very important. And from that, MCQ based questions have been asked repeatedly. Okay, so now you see the solvent is a gas, right? Nitrogen gas. So that means it will be a gaseous solution. So correct answer is option number C here. Now moving to the next question, out of the following, which one is not an example of solution? Now let me tell you, these both are from previous year questions. So if you see, air is a mixture of gas, brass is also alloy, so it is a mixture of solids. Amalgam is also a mixture of solids, but benzene in water, this is an immiscible liquid, so it is not a solution. Option number D here. Next, moving to question number 3, match the following. Okay, so here gaseous solution, liquid solution, solid solution are given, their examples are given, we need to match it. Okay, so in gaseous solution, the solvent will be a gas. So you can see here atmospheric air, air is also a gas, so A will be R. So I can see AR, only one option is there, so option number B here. But let's check the other options as well. Liquid solution, the solvent has to be liquid, so drinking water, so B will be P here, right? B is P. And solid solution, amalgam of mercury with solid, C will be Q here. Now moving to the next question number 4 here, just a minute. Okay, match the items in column 1 with the type of solutions in column 2. Similar type of questions. Soda water. Okay, you know soda water is what? Carbonated drinks, means carbon dioxide gas is dissolved in liquid water. So it is a solution of gas in liquid, right? So one has to be option number E. Do we have that? Yes. So I can eliminate these two. Next one, 2, sugar solution. This is solid in liquid. So sugar is solid, water is liquid. So this is solution of solid in liquid. So 2 has to be C. In both the options it is there. Next, we can see 3. Also you can check air. Air is a, I just told it is a mixture of gases. So it is a solution of gas in gas. So 4 has to be B. So I can eliminate this option. And C, that is German silver. Okay, that is your solution of solid in solid. So we will have option number B here. Now moving to the next question, the concentration term that depends on temperature is. So we have studied this time numerous times that molarity is the formula, is the function of volume, right? It is number of volumes by number of moles by volume, right? And volume is affected with temperature. So that is why the answer here is molarity. Next, which of the following is dependent on temperature? The same answer, sixth one, A, molarity. Next, 7th question, if I move, increasing the temperature of an aqueous solution will cause. Now, if you see, molarity is equal to number of moles by volume. If you increase temperature, volume will increase, molarity will decrease, right? So it will be a decrease in molarity. You can see option A is decrease in molality, not molality, it is molarity. So option number B here. Next, the mass percentage of W by W of glucose in water 10% means. Now see, when I say 10% W by W, that means 10 gram of solute, okay, is present in 100 gram of solution. Okay, that means 10 gram is solute, and what will be the mass of solvent? 90 gram will be solvent, right? So I can say 10 gram of solute or glucose in 90 gram of water. So that is your option number C here. Next, the mass percentage of glucose, W by V is given 10%. W by V, V stands for volume here. So 10% of glucose means 10 gram of glucose in 100 ml of water. Okay, so 10 gram of glucose in 100 ml of water, that is your option number C here. Next, the mole fraction of the solute in 1 molar aqueous solution is. This is an important question. Okay, mole fraction of the solute in 1 molar aqueous solution. Now see, when I say 1 molar aqueous solution, that means what? It is 1 mole of solute in 1 kg of solvent, right? Now 1 kg of solvent means 1000 grams of solvent, and you can see it is aqueous written here, right? That means the solvent is none other than our water. So what is the number of moles of solvent? Number of moles of solvent will be 1000, that is 1 kg is equal to 1000 gram divided by 18, which is equal to 55.5. Okay, now 1 molar aqueous solution means it is 1 mole of solute is present in 1 kg of solvent. So what is the number of moles of solute? I'll just extend here. Number of moles of solute will be 1 mole, right? Now if I want to calculate the mole fraction of solute, right, that is equal to number of moles of solute divided by number of moles of solute plus number of moles of solvent, right? Now you can substitute. This is what I can substitute here. So let me just erase this place, just a minute. So I'll get a little bit of place here. Okay, so just a minute. Okay, so now if I just calculate number of mole fraction of the solute and I substitute the value, it will be 1 by 55.5 plus 1. So 1 by 56.5, and the value that you will get here is 0.0176 something, which is nearly equal to 0.018. Okay, now moving to the next question. If 1 molar of a substance is present in 1 kg of solvent, then, so this is the molality definition. It shows what? It shows molar concentration. Next, a binary solution has two components A and B. The mole fraction of A is 0.5. Then the number of moles of component A and B in the solution is. Now see, mole fraction of A is equal to 0.5, and we know A plus B will be 1. So mole fraction of B will also be 0.5, right? And if I say this is equal to Na by Na plus Nb, okay, and both of these terms are equal, that means number of moles of A and number of moles of B will be equal. Next, the concentration of fluoride ions to be present in water to prevent the tooth decay. Okay, it has to be 1 ppm. So option number A is correct answer here. Okay, now let's see question number 14. The concentration of pollutants in water or atmosphere is expressed in terms of, it is microgram per liter. Okay, so these are some applications of the concentration terms. Next is match the following. The concentration terms are given, their units you have to match. So molarity is equal to what? Moles per decimeter cube or moles per liter. So A has to be S. So I can eliminate this option. Then molality is moles per kg, right? So that is R. So B has to be R. So I can eliminate now this option as well. C is mole fraction. Mole fraction has no unit. So that is T. So I can now find out option number A is the correct answer. Molar mass is gram per mole. So D will be P. And ebullioscopic constant will be Kelvin kilogram mole inverse. Okay, next moving to question number 16 here. The tanks used by the scuba divers are filled with air diluted with helium of around 11.7%. This is done to avoid a medical condition that we call as bends, right? A student took 2 glasses of pure water from water filter. He cools glass A in the fridge and warms glass B on the stove. On comparing the solubility of oxygen in water in glass A and B, he states that glass A contains. Okay, now you see that glass A is at a lower temperature, right? That means for solubility of gases in a liquid, we know that solubility increases when temperature decreases. So glass A will definitely have more oxygen than glass B. So option number A here. Next is question number 18. The dissolution of gas in a liquid is governed by, this is very important question and easy as well, Henry's law. PA and PB are the vapor pressures of pure liquid A and B respectively of an ideal binary solution. If XA represents the mole fraction of A, the total pressure of the solution will be. Now see, if you know the total pressure is equal to what? P naught A XA, okay, plus P naught B XB. Okay, P naught B XB. But you know that this XB can be written as 1 minus XA. Can I write it like this? To just make the equation in the form of XA, I can write this term like this. So I will get here P naught A XA, okay, plus P naught B, right, minus P naught B XA. Okay, so from here I can take XA common and P naught B will be another term present here. So PB and XA taken common here, P naught A, P naught B. So that is option number D here. Next, the vapor pressure of two liquid P and Q are 80 and 60 torr. Okay, so vapor pressure, I can write P naught of Q is 80 and P naught of Q is 60. The total vapor pressure of the solution obtained by mixing 3 moles of P and 2 moles of Q would be. So now if you see, mole fraction of P will be 3 by 5 and mole fraction of Q will be 2 by 5, right? So then what is the total pressure here? Total pressure is P naught, that is 3 by 5 of 80 plus 2 by 5 of 60. If I solve this, I'll get 5 16s are 48 here, and here I'll get 24, right? So it will be around 72. So option number A is the correct answer. Next, which of the following statements about the composition of the vapor over an ideal 1:1 molar mixture of benzene and toluene is correct? So you have a solution, okay? You have here 1:1 ratio of benzene and toluene. Now the question is saying, assume that the temperature is 25 degrees Celsius given the pure vapor pressure of benzene is 12.8 kPa and toluene is 3.8 kPa. Then what is the composition of the vapor? Now you can see that benzene vapor pressure is more, that means it is more volatile. So definitely here benzene pressure will be more as compared to toluene. So the vapor will contain a higher percentage of benzene, which is option number C here. Next, all aqueous solution is 1 molar Ki. An aqueous solution is 1 molar Ki. Which change will cause the vapor pressure of the solution to increase? Okay, and we know that when we add a solute, okay, if you add a solute, what will happen? The vapor pressure will decrease. On addition of a solute, the vapor pressure will decrease. Now you have already 1 molar Ki, means in 1000 gram of water, already 1 molar Ki or 1 mole Ki solute is added. Now if you keep on adding other solutes, the vapor pressure will keep on decreasing, it will not increase. But water is a volatile solvent. If you add extra water, then water will evaporate and the vapor pressure can decrease. So answer here will be option number 2. Okay. Next, question number 23, the mixture which shows positive deviation from Raoult's law is. Now positive deviation means the interaction should be very, very weak. So for that, you know that ethanol and acetone has a weak interaction because ethanol has strong hydrogen bonding, but when you add acetone to it, the hydrogen bonding gets disrupted, right? So option number C here. The mixture which shows positive deviation, again ethanol and acetone. The mixture that shows maximum boiling azeotrope, maximum boiling will also be shown by negative deviation, right? Negative deviation, we have water and nitric acid. This example is very important. Next, question number 28. Which of the following statements is correct regarding a solution of two components A and B exhibiting positive deviation? Okay, there is positive deviation. Intermolecular attractive forces between AA and BB are stronger than those of AB. No, in positive, yes, intermolecular attractive forces of A and BB are stronger than AB. That happens in positive deviation. So this statement is correct. Okay. The question is asking you correct regarding, okay, delta V mix is equal to 0. That is incorrect. Okay, positive deviation, right? It will be greater than 0. Delta H mix and V mix, I think this is delta H mix, this is delta V mix, this is 0, this is also incorrect. Intermolecular forces is equal, this is also incorrect. So the correct statement is option number A here. Next, a solution containing components A and B follow the Raoult's law, means it is an ideal solution. So AA-BB interactions will be equal to AB interactions, which is given in option number C. AB interaction force remains same as AA and BB. Next, all forms ideal solution except. So you can see here C2H5 and C2H5OH, the two different functional groups are there, so they do not form an ideal solution. An ideal solution is formed when its components have no volume change on mixing, have no enthalpy change on mixing, have both the above characteristics. Yes, delta H mix and delta V mix. Okay, both should be equal to 0. Next, 10 ml of liquid A. Okay, 10 ml of liquid, just a minute. 10 ml of liquid A and 20 ml of liquid B. Okay, so total volume should be 30 ml. The volume of the solution was measured to be 30.1 ml. That means what? Delta V mix. If you see, V mix is what? F minus V initial, means 30.1 minus 30, which is equal to 0.1, which is a positive number and greater than 0. V mix is greater than 0. That means what? H mix will also be greater than 0. And this is a positive deviation, right? So it's positive deviation. So option number C here. Next, the mixture that forms maximum boiling azeotrope at a specific concentration is, it is water and nitric acid. Next, match the following type of liquid-liquid solution with their examples. Ideal solution, you will have benzene and toluene. So A will be R here. Okay. Non-ideal solution with positive deviation. Non-ideal solution with positive deviation will have which one? Ethanol and acetone. They will have positive deviation, right? So B will be P, and non-ideal solution with negative deviation is acetone and chloroform. C will be Q. So option number D here. Next is okay. In a solution containing non-volatile solute, the mole fraction of the solvent is 0.9. The relative lowering of vapor pressure is okay. Now, if you see in a relative lowering of vapor pressure, what we get is XB, that is the mole fraction of the solute. So mole fraction of the solvent is 0.9, that means mole fraction of the solute will be 0.1. So the relative lowering vapor pressure will be option number B. Next, during depression of freezing point in a solution, the following are in equilibrium. Liquid solvent and solid solvent are in equilibrium. So option number A. At 25 degrees Celsius, the highest osmotic pressure is exhibited by 0.1 m solution of, okay, highest osmotic pressure. You see the formula pi is equal to I into C into R into T, where I is your Van 't Hoff factor. If the I value increases, the pi value will also increase. So I can see for glucose, it is a non-electrolyte, so I value is 1 here. Urea is also a non-electrolyte, I value is 1 here. Calcium chloride is a electrolytic solute, so it will dissociate. Calcium 1 ion, chlorine 2 ion, so I value will be 3 here, and KCl will give you K plus and Cl minus, I value will be 2 here. So if you see option number C is having the maximum I value, so that will have the highest pi value as well. Next, on the following 0.1 m aqueous solution, which one will exhibit the largest freezing point depression? Okay, delta TF will be maximum in which case? Again, similar question. If you see I value, if it is more, then the delta TF value will also be more. Here I value is 2, K plus and Cl minus. Here it is 1 because it is a non-electrolyte. Al2SO4 whole 3. Total there will be 5 ions here, right? 2 aluminum and 3 sulfate, and here it will be 3. Okay, so you can see that aluminum sulfate 5 ions are there, maximum osmotic pressure will take place. So option number C here. Next, which of the following aqueous solution has minimum freezing point? Okay, the freezing point is minimum. This is an important question. Now see, if there is delta TF is equal to what? T naught TF minus T naught F, right? The depression is taking place. So if you have this delta TF is maximum, that means maximum depression has taken place and the freezing point will be minimum in that case. So wherever delta TF is higher, their minimum freezing point. Where the delta TF is lower, there the maximum freezing point takes place. Okay, so you can see here we need to find minimum freezing point, that means highest delta TF value. Here you can see 0.01 and NaCl is 2, right? So what is the formula of delta TF? It is equal to I into Kf into M. Kf will be constant because it depends on the solvent. So I just have to take I and M value. So I value is 2 here. So I and M will be 0.02. Here I value is 3. So if I multiply 0.005 into 3, I'll get 0.1015, right? Next, if you see for this one, I value is 1. So it will be 0.005. And here it will be 2. So I will get 0.01. So now if you see where the TF value is maximum, it is an option number A. So that is why this will have the minimum freezing point. Next, let's see the question. For 0.1 m solution, the colligative property will follow the order. Okay, so I value you have to check. Here Na3PO4 I value is 4, Na2SO4 I value is 3, NaCl I value is 2. So obviously it is 2, 3 and 4. So option number B here. On assuming complete dissociation, the aqueous solution having the highest freezing point. Yes, this is again an important question. Now you are calculating the highest freezing point. That means delta TF value should be low here. Okay, lesser is the depression. See, suppose all of them had this freezing point. Okay, now you added a solute. There is depression now, right? Someone depressed. This depression happens like this. So this value is delta TF, right? So the one. Now this is the minimum freezing point, this is the maximum freezing point. So where the delta TF value is least, there the freezing point will be maximum of the solution. Where the delta TF value is highest, there the freezing point of the solution will be least. So I want to calculate highest now, so I have to look for minimum depression in freezing point. So here if you see 2 molar, I equal to 2, all are 2 molar. So just we need to take the I value. I equal to 2, 5, 3 and 4. So 2 will have, again the formula is delta TF is equal to I into Kf into M. Here molarity is given, but let's assume it is molality. It is same here for all. Only I value will affect. So the minimum is in option number A, right? Next question number 40, which when compared the delta TF value for 0.01 of glucose and for 0.01 of MgCl2 solution it increases. So delta TF value, here you can see the I value is equal to 3, so we will multiply, so here it will be 0.03. It increases by 3 times, so option number A here. Next, which of the following compounds can be used as antifreeze, that is your glycol? If molality of the dilute solution is doubled, then the value of molar depression constant Kf will be. Now see, molality does not, Kf value does not depend on anything. It depends on the nature of the solvent and temperature, right? So if you change the molality, Kf value will remain unchanged. When mercuric iodide is added to the aqueous solution of potassium iodide, then this is again an important question. Now see, when potassium iodide is there, it will dissociate to give you K plus and I minus, right? So there are two particles, but when you add this mercury iodide, okay, that is Hg I2 plus Ki, there is a complex form, okay, there is one complex form like this K2HgI4 something. The formula is not important, but when I add this HgI2, what happens? From two particles it becomes one particle. Okay, if the number of particles increases, then what will happen? Colligative property will also decrease. Sorry, number of particle decreases, colligative property will also decrease, delta TF value will decrease. If delta TF value decreases, that means freezing point will increase, right? Delta TF value, if this value decreases, I told you it is the difference between, if now less freezing, less depression is taking place, that means the freezing point has increased, so option number A here. Next, coming to question number 44, if molality of the dilute solution is double, then the molar depression constant again remains unchanged. As a result of osmosis, the volume of the solution, now see, when I talk about solution, that means it is the concentrated side and this is the dilute side. So from this to this, the water will flow, so the volume of the concentrated side will increase, okay, gradually increase. Okay, I'll just change this one. Yes. Next one, pure water can be obtained from the process that is reverse osmosis, that is desalination of water. Next, the relationship between the osmotic pressure at 273 Kelvin when 10 gram of glucose, 10 gram of urea and 10 gram of sucrose are dissolved in 250 ml of water. Now see, glucose molar mass is 180, urea is 60 and sucrose is 342. Now if you see the formula of pi, it is what? Given mass by molar mass into 1000 by volume into R into T, right? So if the molar mass is less, then the pi value is higher. Okay, if the molar mass is more, then the pi value will be less. So if I see that I have urea 60 gram is present, which is having least molar mass, right? That means pi value will be highest for P2, okay, and it will be least for P3. Okay, it will be highest for P2 and least will be P3. So option number A here. Next is question number 48. From the colligative properties of the solution, which one is the best method for the determination of molecular weight? It is osmotic pressure. Here a 3-marker long question is asked, why osmotic pressure is the better one, that I have already discussed in the solutions important question video. Blood cells retain their normal shape in the solution which are isotonic to blood. Okay, if there is isotonic, then both the pressures are same, so it will not have any osmosis there. During osmosis, the flow of water through a semi-permeable membrane is from solution having lower concentration only, from solution having higher concentration only, from both the sides of membrane with equal flow rates, from both the sides of semi-permeable membrane with unequal flow rates. Now here many of you may get confused and might mark this answer, that is from solution having lower concentration only, okay, but this is not the case. See what happens when you have this semi-permeable membrane, okay, there is gaps in between, right? So this is, for example, the higher concentration side and this is the low concentration side, but this semi-permeable membrane is such that only solvent particles can pass through it. So the water molecules which are present at this border, they will pass this side, and the water molecules present here will come this side, okay. So there is flow on both the sides, but the net flow is from the lower concentration to higher concentration, the net flow, but the movement of water across the semi-permeable membrane takes place from both the sides in unequal rate, okay. So from both the sides of the semi-permeable membrane with unequal flow rate. Next is question number 51. Solution A containing FeCl3 solution is separated from solution B containing K4FeCN6. Okay, so one side we have FeCl3 and another side we have this complex. Now, if FeCl3 reacts with this particular compound, then you will get a blue color solution. The blue color will appear in A, B. So this side is A, this side is B. In both A and B, neither A and B. See, For this reaction to happen, the solute particles must react with each other, but the semi-permeable membrane does not allow the solute particles to pass through it. So that means there will be no reaction here, so it will be neither A or neither B. During osmosis, the solvent molecules are moving from higher osmotic pressure solution to the lower osmotic pressure solution. Okay. Next 53 question, relative lowering. Okay, this question answer in the answer key provided by the PU2 board, it is wrong. Okay, I have given you the correct answer here in this video. Please check this. The answer given in the solution is wrong for question number 53. Okay, relative lowering of vapor pressure is your option number 3, right? So A will be 3, we will eliminate these two. Henry's law, B will be 4, right? Both are having that one. Depression in freezing point is your C1. Okay, C1, and D, cryoscopic constant, is this formula, which is your D2. So correct answer is option number C, but according to the answer key given by PU2 board, the correct answer mentioned is A. Okay, it is not the correct answer. C is the correct answer. Okay, next question number 54, a similar question here. Raoult's law is equal to this one, that is the total pressure. So A will be 3, I can eliminate these two options. Elevation in boiling point kbm, so B will be 4. Ebullioscopic constant C will be 1, and osmotic pressure CRT, D is equal to 2. So option number C here. Next is, which one of the following salts has the same value of Van't Hoff factor as of K3FeCN6? Here coordination compound concept is also used. You know, this complex will not break, only potassium will break to give you 3K plus, and this particular ion, this particular complex will form FeCN6 3 minus, right? So total number of ions produced here is 4. So now if you see Na2SO4, I value is equal to 3, Al2SO4 whole 3, I value is equal to 5, AlNO3 whole 3, so I value is equal to 4 here, and I value equal to 2 here. So you can see that option number B is the correct one. Next, the Van't Hoff factor I for a compound which undergoes dissociation in one solvent and association in the other solvent is respectively. So when it is undergoing dissociation, the I value will be greater than 1, and when it is undergoing association, the I value will be less than 1. So option number D here. Next, compare these compounds with their Van't Hoff factor value. I is greater than 1, that means it is dissociation. A will be 2, right? So only one option is there, so that is option number A. I less than 1 means there is association, so B is 1. I equal to 1 means there is no association or dissociation. I equal to 0, that means that is not possible. Okay, impossible. Okay, next question here are your statement based questions. Okay, two statements are given. If both the statements are correct, then you have to select option number A. If both the statements are incorrect, then you have to select option number B. Statement 1 is correct, statement 2 is incorrect, then option number C, and statement 1 is incorrect, D is like statement 2 is correct, then option number D. Okay, so now we will see some questions from here. See, 1 molar aqueous solution has always higher concentration than 1 molar solution. Now this statement is very, very important, and it is correct statement. Okay, see, in 1 molar, when you have 1 molar, what is it? Number of moles in 1 liter of solution, right? Here this 1 liter of solution contains both the volume of the solute and the solvent, right? But the molality is what? Number of moles in 1 kg of solvent only, right? So here the solvent amount is less because it has both solvent and solution. Now if you see, in a lesser amount of solvent, more 1 mole is present, but in case of this one, in 1 kg of solvent, 1 mole is present. So since here the solvent amount is less, which is in denominator, the concentration will be higher here. So this statement is correct. 1 molar solution contains less solvent than 1 molar solution. Yes, because it is the volume of both solute and solvent is there, so it has less solvent. So this statement is also true. So answer will be option number A here, right? Both the statements are correct. Now next one, question number 59 here. 1 molar aqueous solution has always a lower concentration than 1 molar. Now again, this one is important. You can see it is saying 1 molar is having lower concentration, but just now we discussed 1 molar is having higher concentration. So this statement is incorrect. The molality of a solution depends on the density of the solution, whereas molarity does not. Again, this statement is wrong. See, molality depends only on the mass of the solvent. Okay, it doesn't have to do anything with the density. But molarity depends on volume. When you change the temperature, volume changes, density changes. So that is why molarity depends on density, but not molality. So both the statements are incorrect. So here the correct answer will be option number B. Here I want to just mention, okay, just a minute, that this particular question, okay, statement question number 59, answer given in the KEA answer key is wrong. Okay, what is the answer they have given? So just let me write down that also. The answer given is B. Okay, so the answer given is C. The answer given is C here, but the correct answer will be B here. Please mark this one. Okay, now let's move to question number 60. Okay, 60 question is, greater the value of Henry's constant in a particular solvent, greater is the solubility. This is incorrect. We know KH is inversely proportional to solubility. Greater the KH value, lower is the solubility. This statement is incorrect. Solubility of a gas is directly proportional to Henry's constant. No, it is inversely proportional. So this is also incorrect. Both the statements are incorrect. So option number B here. Next question number 61. Just let me move ahead. Okay. On adding NaCl to water, the vapor pressure increases. No, we have studied that on adding a solute, the vapor pressure decreases. So this is incorrect. And then addition of a non-volatile solute increases the vapor pressure. No, it again decreases. Both are incorrect. So option number B here. Next statement, question number 62. If a liquid solute more volatile than the solvent, okay, if a liquid solute more volatile than the solvent, then the solute is added to the solvent, the vapor pressure of the solution may increase. P S is equal to P naught. Yes. Now see, what is the vapor pressure, total vapor pressure? It is the vapor pressure of the solvent and the solute. Now since the solute is more volatile, obviously it will evaporate more, so the vapor pressure of the solution will increase, right? So this statement is correct. In the presence of the more volatile solute, only the solute will form vapors and solvent will not. Why? Solvent was already volatile, right? Solvent will keep on evaporating, but solute, since it is more volatile, it will start evaporating more, but solvent will also evaporate. So this statement is incorrect. So statement 1 is correct, statement 2 is incorrect. So that is your option number C here. Next question number 63. If on mixing the two liquids, the solution becomes hot, okay, that means energy is released here. Delta H is negative. That means it implies a negative deviation. Yes, that is absolutely correct. Solutions which show negative deviation are accompanied by decrease in volume. Yes, negative deviation, more attraction, volume decreases. So this statement is also correct. Both are correct. So option number A here. Okay, so just a minute. Okay, now let's move to the next question, that is 64 question. Okay, vapor pressure of water is less than 1.013 bar at 373 Kelvin. See, 373 Kelvin is 100 degrees Celsius. The water boils at 100 degrees Celsius. The vapor pressure of water is equal to the atmospheric pressure. So this statement is incorrect. Water boils at 373 Kelvin as the vapor pressure at this temperature becomes equal to the atmospheric pressure. This statement is correct. So statement 1 is incorrect, statement 2 is correct. So that is your option number D. Again, here I just want to highlight this particular question. Okay, just a minute. Sorry. Yeah. 64, I would just want to highlight the answer given in the answer key released by the PU2. This answer is also incorrect. The answer that is given by the PU2 board for this question is option number A. Okay, they have given option number A, but the correct answer will be D here. Okay, I have just noted down, so I'm just checking it. So answer given by PU2 board is A. Please remember, this is wrong answer. Moving to the next question, 65 question. Let me change the ink, 1 second. Okay, 65 question, you can see isotropic mixtures are formed only by non-ideal solutions and they may have boiling points either greater or less than both the components. Yes, that is correct statement. Composition of vapor phase is same as that of liquid phase. That is also correct, and that is why we cannot separate them through steam distillation. So both the statements are correct. Option number A here. Next is statement 1. 66 question. Cooking time in pressure cooker is reduced. Yes, that is correct. And boiling point is increased. That is because of addition of solute. So boiling point will increase. Again, both the statements are correct. So option number A here. Statement 1. Addition of a non-volatile solute to a solvent increases the boiling point. Yes, there is an elevation in boiling point. Addition of a non-volatile solute results in the lowering of vapor pressure. This is also correct. Both the statements are correct. So again, option number A here. Next, let's move to 68th question. The depression in freezing point depends on the amount of solute dissolved and not on the nature of the solute or solvent. Yes, it is a colligative property. So it will depend on the amount of solute added, right? For aqueous solution of different electrolytes, the molar depression constant will have different values. No, see, the aqueous solution, the molar depression constant is solvent specific. Okay, since you have taken aqueous solution means you have taken water as a solvent, so the Kf value will remain constant. So this statement is correct, this statement is incorrect. So first statement is correct, second statement is incorrect. That is your option number C here. Okay, next 69th question. 0.01 m aqueous solution of glucose has higher increment in freezing point than 0.1 m aqueous solution of urea at the same condition. Okay, now if you see the increment in the freezing point delta Tf, okay, all the colligative properties are inversely proportional to molar mass. So if you see glucose molar mass is 180 degree, right? So that means here there will be lesser increment, whereas urea molar mass is 60, here there will be higher increment. So the first statement, the 0.1 glucose has higher increment, that is wrong. Why? Because here the molar mass is less, right? Has higher increment in the freezing point than 0.1 m aqueous solution of urea at the same condition. So this statement is incorrect. Then Kf for both has different values. No, since the solvent is same, Kf is same for both. So this is also incorrect. Both the statements are incorrect. So the correct answer for this question will be option number B. Now again, here this question I want to highlight 69. Okay, just a minute. Yes, 69th question. The answer given in the answer key released by KEA is different. The answer that is given there by KEA is B for this question. Okay, is B, which is not correct. Sorry, C is given. Just a minute. I did a small mistake here. Yes, C is given. Okay, which is not correct. Okay, B is the correct answer. Now let's move to question number 70 here. Higher the molar depression constant. Okay, higher the molar depression constant of the solvent used, higher the freezing point of the solution. No, see, delta Tf is equal to Kf dot m, right? If this value is higher, then delta Tf value will also be higher. And if delta Tf value is higher, means difference is more. That means the freezing point has decreased to a greater extent, right? So that means the freezing point of the solution will be lower, not higher. Okay, so this statement is incorrect. Depression in freezing point does not depend on the nature of the solvent. Okay, depression in freezing point depends on the does not depend on the nature of the solvent, right? So this is again incorrect because different solvents will have different Kf value, so it depends on the nature of the solvent. So this statement is also incorrect. Both are incorrect, so option number B will be the correct answer. Again, this question answer is given incorrect in the in the PU2 question bank. So this answer given by the PU2 board was actually, let me just check, for question number 70, the answer given was C. Okay, but again this is wrong. The correct answer is option number B here. Now moving to 71st question here. Let me just change the ink. Yes. Out of the various colligative properties, osmotic pressure is used for the determination of molecular mass. Yes, that is correct. Polymer solutions do not possess constant boiling or freezing point. No, that is not the reason why we use osmotic pressure. This statement is wrong. The reason that we use is here for even for all a small amount of polymer, we get a very big value which helps us in easier calculation. So statement 1 is correct, 2 is incorrect, so it has to be option number C here. Again, this one is given wrong in the PU2 answer key. Okay, so I'm highlighting it. The answer given by the PU2 board for this question was, one second, it was A. Okay, for 71 it was A was given. Okay, but this is not correct. The correct answer will be option number C here. Now let's move to question number 72. One second, let me just change the ink. Okay, so any concentration of NaCl solution can be injected intravenously, being a common stable salt is harmless chemical. 0.9% of NaCl solution is isotonic with the blood. See, any solution cannot be added. We need to add that injection which is isotonic with our blood solution. So 0.9% of NaCl solution is only safe for the human injection. So this statement 1 is incorrect, but statement 2 is correct. So it has to be option number D here, which is the correct answer. Next, if red blood cells are removed from the body and placed in the pure water, the pressure inside the cell increases. So if you know the concentration inside the cell is 0.9%. Now if you keep it in a pure water, water will flow inside it, endosmosis will happen and the cell wall will feel the pressure will increase. Now the concentration of the salt in the cells increases. No. Now see, 0.9 gram of NaCl was there. Okay, now what will happen? The vapor pressure, now you have added more volume, right? So if the volume will increase, the concentration will decrease. So this statement is correct, but this statement is wrong. So the correct answer will be option number C here. Next, 74th, the molecular weight of acetic acid determined by the depression in freezing point method in benzene and water is found to be different. Yes, it will be different because in benzene and water, both are different solvents. In one case, it is undergoing association, in other case, it does not. So this statement is correct. Water is polar and benzene non-polar. That is also correct. Both the statements are correct. So option number A here. Next, Banter factor for benzoic acid is less than 1. Yes, because it undergoes association. So this is correct. Benzoic acid behaves as a weak electrolyte. Yes, benzoic acid is a weak electrolyte. So both are correct here. Option number A. Okay. Now let's do some fill in the blanks question as well. Desalination of water is based on reverse osmosis. So I'm just putting options here. It is option number 1. The shrinking of a plant cell due to the overflow of water is called as shrinking of, that means the water will go out, that is called as plasmolysis, which is option number 2 here. Okay, hydrated salts are the solutions of liquid in solid, right? So option number 3 here. 22 karat gold is an example of, so gold is an example of solid solution, so option number 4 here. According to Henry's law plot, the equilibrium according to Henry's law, the plot of equilibrium pressure versus dash is a linear slope with slope equal to k. So with mole fraction, from the equation only we know this is from mole fraction. Okay, next is red blood cells are isotonic with 0.9%. Okay, so that is our blood pressure, osmotic pressure. For non-electrolytes, the Venter factor is equal to 1 because they don't associate or dissociate. Greater the value of Henry's constant of a gas, greater the value of Henry's constant, lower will be the solubility. Okay, this is 3. Next, an ionic compound dissolves in water. An ionic compound dissolves in water if the hydration energy is higher than the lattice energy. A solution in which no more solute can be dissolved is called as your saturated solution. Okay, you have 1, 2, 3. Actually, this is 4 and this is 5. Okay, so this is 5. Moving to the next one. In deep sea diving, the disease called Benz is caused due to the dissolution of nitrogen gas. Okay, excess of nitrogen gas in the blood. At altitude, the concentration of oxygen is reduced in blood and people feel weak and unable to think properly. Solutions having the same osmotic pressure are called as isotonic. A solution with lower osmotic pressure is called as hypotonic, and the semi-permeable membrane generally used in reverse osmosis is your cellulose acetate. Next is set 4 will do. Osmotic pressure is the minimum pressure that must be applied on the solution site, right, to prevent the entry of the solvent from the to prevent the entry of solvent from solvent to solution. In osmosis, there is a net flow of solvent from solvent to solution, okay, from solvent side to solution side. Next, if Venter factor is less than unity, this shows that the solute undergoes association. Okay. If Venter factor is more than unity, this shows the solute undergoes dissociation. The constant boiling mixture of two miscible liquids of a definite mole fraction is called as azeotrope when they have a same boiling point. Next, set 5, we have molar elevation constant Kb depends on the nature of the solvent. Colligative properties depend on the number of dash particles dissolved in the number of solute particles. Next, the value of Henry's constant Kh increases with the increase in temperature. Okay, Kh is a function of temperature. As solution is an exothermic process, the solubility, as dissolution is an exothermic process, the solubility should decrease with the increase in temperature. Okay, exothermic process, that's why. Sea divers for breathing inside use the mixture of oxygen and helium gas. Okay. Now let's discuss set 6. People taking a lot of salt develop swelling or puffiness, and this disease is called as your anoxia. At the same temperature, nitrogen gas is less soluble than oxygen. Oxygen is more soluble. The best colligative property to measure the molecular mass of the polymers is osmotic pressure. A dash solution showing negative deviation, a non-ideal solution. Next, less is the colligative property. So you know colligative properties are always inversely proportional to molecular mass. If colligative property is less, molecular mass will be more. So that is your option number, this one, more. Next, we'll do the last set of fill in the blanks. The most common freon used in industries is CCl2F2. As the temperature decreases, the solubility of gas in liquid increases. Next, when a non-volatile solute is added to the pure solvent, the freezing point of the solvent decreases. Then the utility or importance of solution in life depends on their concentration. Okay. Then we have the sum of mole fractions of all the component in a binary solution is equal to 1. So students, these are the most important MCQs and FIB for the chapter solutions, and I hope you have understood. If you have any doubt in any question, do let me know in the comment section, okay? And I hope that all of you have completed the challenge, or at least started the challenge and are on the way to complete it. So just let me know in the comment section if challenge is completed and ongoing or not started. My dear children, if you haven't started, please go download the PDF and solve the most important questions. That much if you do, your preparation will be done properly. So the link is there in the description section. Do not miss. Okay. Thank you so much. All the best and see you tomorrow with the next challenge.